All right, by request, section 6.3, number 5. Again, I'm in a public place, so I'll be very quiet here. But we're asked to find the volume of the region when it's rotated about the y-axis, bounded by e to the x negative x squared, x equals 0, y equals 0, and y equals 1. Oh, I think it's supposed to be x equals 1. Yes, it's supposed to be x equals 1, so let me get that out of there. All right. I'd drawn it correctly. I just stated it incorrectly there. When you rotate that around, you will get this interesting looking tent-like volume. Okay. And each of these things is just rotating around, creating a sharp pointed volume there. You'll have a band down here as well. If you did this using disks, you would have to do two sets of volumes, right? So you'd have a disk like this rotating around, and it has its own boundary. Then you have a disk like this rotating around, and it has its own boundary, right edge boundary that changes. So that's probably not the most advantageous way to do this problem. So instead, we're going to do shells. We're going to just take a vertical slice here and rotate that slice all the way around. And when you do that, you get this. So you have this shell right here. Try my best to draw this out freehand. And it has a bottom here. And in the background, that rotation continues. Right, and there's also a hole in it. Looks pretty terrible, but it is what it is. And then there's some edge. It's a hollow shell. And the volume given by that slice is 2 pi r, that'd be the circumference, times its height, times its thickness, and the thickness there is a delta x. 2 pi r h delta x. So let's talk about what each of these elements are. R is the radius of rotation from the center of the rotation out to that edge. That is an x value. The height, on the other hand, of that slice, that is just a y value. And of course, we need to trade out that y value for what y is. The height at that moment, this height right there, is actually this function, y equals a negative x squared. E to the negative x squared, sorry. 2 pi x sub I e to the negative x sub I squared delta x. And now I'm ready to take the volume again. When you do this volume, you're doing these slices from x equals 0 to x equals 1. So the total volume will be the integral from x equals 0 to x equals 1, 2 pi x e to the negative x squared dx. And of course, you can use a u sub there. We're going to let u equal negative x squared, so that du will steal away a negative 2x dx. I happen to have an x dx to steal away, and even a 2. So all that will be traded out for a negative du. So I'll just do this. When x is 0, u is 0. When x is 1, u is a negative 1. And, sorry, I wrote my negative twice there. You can get rid of that negative by switching the limits. And integrating. That's it.